Okay, so welcome everyone to the RSS workshop on visual learning and reasoning for robotic manipulation. I hope you're all enjoying the conference so far. So first I'll start with some motivation for this workshop. Why do we need a workshop on visual learning and reasoning for robotic manipulation? So first let's talk about what a robot is. So a robot typically receives as some sensor inputs. These inputs get processed by a perception system. That system outputs some representation of the environment that gets processed by a planning and control system that decides what actions the robot should take. And so typically the people who work on the perception system are known as vision researchers, and the people who work on the planning and control system are called robotics researchers. And these groups of researchers don't always talk to each other, unfortunately. But this workshop is asking the question, can we build a better robotic system by thinking about these parts together? And so for example, the perception system can be designed in a way that can make the planning and control system more robust. And alternatively, the robot's interaction with the world can be used to help build better perception systems. So that explains why we need a workshop on visual learning and reasoning for robotics. But the other part of the question is, why do we need a workshop on visual learning and reasoning for robotic manipulation specifically? So to motivate why we choose to focus on manipulation, let's look at some recent results in the area of robot learning. So here you can see an example of a robot that's learning to drift as it drives very quickly around this racetrack. This is work by groups at Georgia Tech. There's also some recent work on teaching a quadruped robot, how to get up from varying lying down positions. There's work on aerial flight that's teaching robots how to navigate around these indoor spaces in varying lighting conditions. And there's also been a lot of work on autonomous driving recently through various companies. And so one thing that we noticed throughout these works is that the main objective is basically to avoid collisions, to avoid contact with the environment. Whereas in manipulation, the robot needs to make contact with the environment. It needs to perceive the diversity of objects that it might find in varying environments that the robot might be for manipulation tasks. And it needs to figure out how to interact with these objects. So there are many tasks that a robot currently cannot do. Here I'm listing just a sample of them: cooking, laundry, cleaning, fixing things, or building things, opening. But there's many other tasks. And these are the types of tasks that fall into the domain of manipulation. So maybe if we develop better manipulation methods and better perception, better integration of perception and manipulation, we can teach robots how to accomplish these tasks. So the next thing that you might ask is, well, do we really need to improve computer vision anymore? I mean, computer vision is already really good, right? Here's a result from MaskR CNN from 2017. So this method takes as input an image and segments it to find all the different objects in the environment. And so if you look at this and you attend a computer vision conference today in 2020, you might say, basically, we're done. We just need to solve the robot side of the problem, but the vision side is solved. So, so here's a couple of examples of robots interacting with their environment. And in each of these cases, you can see that the robot has not correctly perceived its environment. So it kind of makes mistakes about where objects in the environment are in order to figure out how it should act. And so the question I'm sure is on all of your minds right now is, why didn't MaskR CNN fix this? I'm just kidding. I think it's actually fairly clear that just plugging in MaskR CNN into this robot pipeline is not sufficient to make the robot actually function properly, we need to think more about what are the questions that robots need for computer vision systems to answer, and how do we design computer vision systems to help robots to do those tasks rather than treating a computer vision maybe in isolation. So this workshop is about thinking about how can we build a better system by thinking about these parts, the perception and the planning and control parts together for robot manipulation. So that brings us to the workshop that we have today on visual learning and reasoning for robotic manipulation. So now let's go into the workshop logistical details. There are 8 conference organizers who helped to put this workshop together. So myself, David Held from CMU, Quan Feng from Stanford University, Yuk Zhu from UT Austin and NVIDIA, Dinesh Jayaraman from University of Pennsylvania, Animesh Garg from University of Toronto NVIDIA, Lin Sun from Samsung, Yu Sheng from NVIDIA, and Greg Dudek from McGill and Samsung. The 4 organizers shown here will be moderating some of the sessions today, and Greg will be moderating the final panel at the end. So we'd also like to thank our sponsor, Samsung, who has helped us with some of the workshop organizational details and also generously provided the award for the best paper that we will announce shortly. So we also have an exciting lineup of invited speakers who will give talks on varying topics relating to the theme of the workshop. So this is the set of speakers. I hope you're all excited and looking forward to hearing their talks. We have also received a large number of submissions that from submitted papers that we went through and chose the best ones. Here are the papers to be accepted. So each of the paper authors will be presenting these papers today as well. And so among those papers, we had a vigorous debate over which paper would receive the best paper award. And so I'm happy to announce that the winner of the best paper award goes to KPAM 2.0, Feedback Control for Category Level Robotic Manipulation by Wei Gao and Russ Hidrick at MIT. So congratulations, you'll be receiving a $1,000 gift card for Samsung that was provided by our sponsor, Samsung, of course. So congratulations to you again, and we'll be hearing that paper later today. So here's the agenda that we have for today. So I'll sort of go through this agenda in more detail in a moment. But first, something you might be wondering is how can you participate in the workshop? So there's 3 different ways that you'll be able to participate. The first is by asking questions after each of the invited talks. After each one, there will be a 5-minute Q&A session. Also, after each group of spotlight talks, there will be a 10-minute Q&A session that you can ask questions as well. And then at the end, there will be a panel discussion that you can ask questions to the panelists. So, so this is the agenda that I showed. And so breaking this down, we have different, the talks shown in yellow are the invited speakers. And remember, after each one, there will be a 5-minute Q&A, so you can ask questions to those. There's these 2 spotlight sessions, and after each group, there will be a 10-minute Q&A. And at the very end is the panel discussion that you can ask questions for. So, so a couple of notes about your interaction with us. So first is that this webinar is being recorded, and by your attendance at this virtual event, you acknowledge that you have been informed and consent to be filmed. If you are sharing your video, and your chat will be recorded as well. Also, the item number 2 is that the attendees' audio and video options will be turned off. So those are 2 notes. And how can you ask questions? So we're going to be hosting a Q&A session with each speaker. And if you have a question during the presentation, you can submit it through either the Q&A or the chat tool. The audio, you won't be able to use audio. So those are the two ways that you will be able to ask questions. You're highly encouraged to ask questions. Actually, we will be raffling away gift cards to attendees who ask questions. So in each sort of group, we'll keep track of who asked questions, and among the people who ask questions, one of them will be selected for receiving a gift card. So if you want that, you should ask questions. Great. So that's all I have by way of introduction. And if there are no questions, we can begin with the first session.